Hey guys, this is Carrie, and in this video we're doing our answer key for homework number 4. So, in the box below, write the formula we discovered in class for the sum of the first n terms of a geometric series. On the side, identify the meaning of each of the variables. So we found that if we want to add up the terms of a geometric series, the formula is a1 minus a1 times r to the nth power all over 1 minus r. And identifying the variables, s sub n is the sum of the first n terms. So if we wanted to add up 10 terms, that would be like 10 here. N is the number of terms. And that comes up in the formula in a couple of places. It comes up here. So if we wanted to add up 10 terms, it would be s sub 10. And it also comes up here, so the power always matches the subscript. A1 is the first term, and R is the common ratio. And for me, this was a real highlight of the class in terms of thinking about the whole year. It was like we're able to completely derive this formula and see where it came from. It comes from the shift method, and that was pretty exciting. So seeing the use of this formula is also exciting. So let's see how it applies in problem 2. Jeremy's training to compete in a bike race. He bikes 150 miles in the first week of training. In each week, he bikes 1.1 times as many miles as the week before. Then rounded to the nearest tenth of a mile, how many miles will he have biked by the end of his 12-week training program? So it looks like in the first week, Jeremy bikes 150 miles. In the second week, he's going to bike 1.1 times as many. So we multiply this by 1.1, and I believe we get 1.1 would be, I think it's 165. Just check that calculation. Next up, if we multiply it by 1.1 again, it will tell us how many miles he's biked in the third week, but it's like kind of a decimal. And what this starts to hint at is this idea of, yeah, we could find all 12 weeks and then add them up, but this is going to be a pretty arduous process because of getting decimals. So instead, if we want to find the total number of miles that he biked in this week, that would be what we'd get when we added these up. It sounds like we're talking not about a sequence here, but a series. So we need the series sum. And probably the best way to do this, once we notice that it's multiplying each time, is to use our geometric series formula. So that will give us the sum of the first, he's 12 weeks is his training program. The sum of the first 12 weeks is equal to the first one, 150, minus the first one, 150, times R. The common ratio is 1.1 to the nth power. Since it's 12 weeks, it's 12 as the power, all over 1 minus R. And R is the common ratio. So just off to the side, identifying the variables because it might be useful. A1 was 150, R was 1.1, N was 12, and S sub N is the thing that we're looking for. All right, so put this all in your calculator and see what you get. And I'll do that here as well. So I'll go into Desmos. So we're supposed to do, let's see, a division problem, 150 minus 150 times 1.1 to the 12th power, all divided by 1 minus 1.1. So 3,208 miles, rounded to the nearest whole number. It's a lot of miles, but I guess he's got 12 weeks to do it. You'll probably need a calculator to compute each of the following. However, before using a calculator, make sure to write down any calculations that you do. What is 16% of 1,500? So 16% is 16 over 100, which is 0.16. So we're going to do 0.16 times 1,500. You should use your calculator to do that. So we go over to Desmos, 0.16 times 1,500, 240. What is 116% of 1,500? So this would be divided by 100, 1.16. So we do 1.16 times 1,500, and that gives us 1,740. 84% of 1,500, that's going to be 0.84 times 1,500 after doing the division by 100. So that gives us, let's see, that's going to give us 1260. 184% of 1,500, that's going to be 1.84 times 1,500. And I might get this one wrong, but I think that that is going to be 2760. All right. Which of the following parts in the previous question computed a number that was 16% more than the original value? So when we think about 16% more than the original value, it means we have the original amount, 100% of the original amount, which is the same as the starting amount, plus 16% more. So that would be 116%, which was part B. Which parts from the previous question computed a number that was 16% of the original value? So 16% of the original value, that's just 16%. And that would be part A. Which of the parts from the previous question computed a number that was 16% less than the original value of 1,500? So 16% less than the original value would mean you had the whole 100%, and then you lost 16% because it's 16% less, which would be an 84% when you do the subtraction. So this is part C. The sequence is generated using the following rules. A1 is 700. Each successive term is 30% more than the previous. 30% more means we have the original 100% of the previous plus an extra 30%. So we get 130%, which when we do the division by 100 is 1.30. So each term is 130% of the previous, so we're going to do times 1.30 times 1.30, and let's see what that gives us. So for A2, we do 1.3 times, actually, sorry, let me just clear that out. 700 times 1.3, 910. And then we have to multiply by 1.3 again. So I'm just going to do another times 1.3 here, which gives us 1183. So that's A3. So a recursive formula is one that depends on the previous. So A1 is 700, and A sub n is equal to the previous one, the n minus 1th term, times 1.30. And we need both parts, the initial condition and the next rule, in order to get full credit. So make sure you have it. A sequence is generated using the following rules. Okay, you do that one. For this problem, round your answers to the nearest dollar. So I like this one a lot. An employee makes $60,000 in their first year at a job. Each year, they earn a 3% raise on this annual salary. If they work at the job for 30 years, then let's see what happens. So their first year, they earn $60,000. Because they're getting a 3% raise each year, it looks like the amount they're going to make each successive year, each future year, is 100% of what they made the year before, plus the extra 3% raise. This means that they're going to make 103% of their previous salary. Converting that to a decimal gives us 1.03. So, to get the second year salary, we'll have to take this number and multiply it by 1.03. So we go over to our calculator. 60,000 times 1.03, $61,800. So they get a nice little raise there, $1,800 raise in that first year. For their third year, we'd have to do the same thing. They would make another 3% raise, so it'd be 100% of what they had, plus the extra 3% again. So we pop over to our calculator, so times 1.03. So that's 63,654. Oops, 63,654, I believe. Let's see if we got that right. Yep. Okay. So we could keep doing this for a while, but the goal is to figure out how much they make in their 30th year at the job. So that would be their salary in the 30th year. Let's see. we've got two choices. We could use either the recursive formula or the explicit formula. And in this case, I think the recursive formula is going to be a pain to do because we have to find all the salaries in between. So let's use explicit formula instead. So in order to build up to this, you could think to get up to A3, we had to start with 60,000, their salary in the first year, and then we multiplied by 1.03 twice, which is 1.03 to the second power. To get their salary in the 30th year, we'd want A sub 30, and that'd be similar. Start with 60,000 and multiply by 1.03. Instead of 2 times, there are 29 steps to get from the first one to the 30th one. So we'll multiply by that to the 29th power. And I've got to use Desmos to compute this. So 60,000 times 1.03 to the 29th power. They're making quite a nice salary here, $141,394. $194,394. I think I got that wrong. Let me look that up. $141,394. 141,394. 141,394. It's hard to remember. All right, so they actually reached a pretty reasonable salary from those 3% raises. Now, part B gets at a really interesting follow-up question, which is how much will they make in all 30 years at the job? So it looks like what we're supposed to do then is we're supposed to add up all of the years to get their overall salary. So when we add up all the years, that starts to sound a lot like a series, which is an exclamation point. And in fact, we can identify because it's multiplying by 1.03 that it's a geometric series, which means that to compute it, we get access to not only the shift method, but also our formula. So it looks like we're trying to add up the first 30 years of our salary. So we're going to have A1 from the formula, 60,000, minus A1, 60,000, times R, the common ratio, 1.03, to the nth power, 30th power, all divided by 1 minus R, which is still 1.03. So using our calculator to compute this gives us 60,000 minus 60,000 times 1.03 to the 30th power divided by 1 minus 1.03. So over the course of their entire career, they make 2,854,524. 2,854. This is going to be impossible to remember. 2,854,524. 2,854,524. 2,854,254. Oh, rounded wrong. 255. So I'm saying that number like that because it's easier to remember, but really this is $2,854,255 that they've made over their entire career. And that's pretty interesting, I think. This is the way that a lot of salaries work. You get a certain percent raise each year. It also could be the way that, maybe an investment strategy works or something like that, but we're able to figure out over the course of this person's lifetime how much money they make. So I hope you guys found this interesting and helpful. See you in class on Thursday.